Hi everyone. Thanks for giving me a chance to present my paper titled Architecture Description Framework for Data Intensive Applications. On behalf of the author, Professor Henry Muccini, Professor Muhammad Sharaf, I'm going to present our paper. I am Mu'min Abu Ghazali. I am a postdoctorate researcher at L'Aquila University, Italy. I have different experiences in academic and industry. In this presentation, I'm going to talk about data architecture and data intensive. What is the state of the art of data architecture? Then we will talk about literature review, modeling data architecture, and the graphical tool on top of the meta model, and finally, the evaluation for the framework. First, let's talk about data architecture. In general, what does it mean not to have a data architecture? Not having a data architecture is like building a house with no plan, with no blueprint. You might end up with something, but it will not be what you need or want. Trying to navigate through a forest without a map, you might eventually find your way, but you will waste a lot of time, energy, and resources. For data intensive, we use it to handle, process, manage large volume of data. Example of the application: big data analytics, data mining, scientific simulation, machine learning, and etc. The idea from data intensive processing of massive data sets, processing different formats, structure, and semi-structure and structure, extract valuable insight, extract pattern, extract information from the data. Data intensive, it is necessarily to take an action or make a decision based on the data. Especially, we have different data sources that generate data in different format at different speed that need to think about how to store the vast increasing of data. To achieve data intensive, we need a best way to collect, store, analyze, and protect valuable data. One of these way is a data architecture. Data architecture is a way to collect, store, process, and analyze data to gain insight and make data-driven decisions. In the current study are limited to identifying challenges instead of offering a solution, providing specific meta model for specific stages of the data lifecycle, providing architecture based on technologies, proposing conceptual model for data pipeline. We find no comprehensive meta model to be a base for data architecture modeling. We developed a architecture description framework as a modeling and analysis framework that will help facilitate an architecture-driven development of data-intensive application that describe a data flow for data-intensive application from the source to the final destination, that has a ability to provide high-level, low-level architecture, uses the advanced model-driven engineering technique, which is a meta model. To do that, we conducted a literature review to identify the primary components of data architecture. We discovered the main concepts like a data format, structure, semi-structure, and structure, processing type, data storages, location, generation, ingestion, processing and storing data, analyzing and consuming the data. In our research, we adopted a model-driven engineering methodology to model data architecture by utilizing the advanced technique of meta model. For that, we developed meta model, structural and behavioral as a basic definition of software architecture a collection of component and connection together with a description of the interaction between these component and connector. For that, our meta model contain the component, we call it data node, and the connection between the component. Data node contain two basic things, data representation and the node behavior. Data representation include data format, data storages, data location, and the processing type. For behavioral model, we have two basic things, event and action. When receiving the data, which action could I do? The action represents the main data operation on the data, like generation, ingestion, processing, store, consume, or analyze, or verify. On top of that, we developed a graphical modeling tool. We call it ADAT. We use it a modeling Eclipse modeling framework, eCore, that includes a meta model for describing the model. For the evaluation, we have 5 real cases evaluated done by 7 industry professionals from 2 companies of different domain and researcher to check expressiveness. The table below show the roles of the experts who participated in the evaluation. The complexity of each cases represent with the number of node and the number of data element include the node. These cases include analytical data warehouse, operational data warehouse, data pipeline, Lambda architecture. The second table shows the case and the main component needed to model the case. As a result, our framework can model a data architecture that has the main data element and component, which has the ability to describe big data, volume, variety, and velocity, store the data in different location, in different storage, processing type, batch and real time, sharing the data, make the data availability, and analyze the data, descriptive, diagnostic, predictive, and prescriptive, and visualizing of how to present the data, chart, dashboard, etc. On the personalization, that's the thing that we need to cover in the our future work. For the modeled cases, here's the application of that for these cases. First, we have model for error data pipeline that show the data is generated from printers in JSON format inside a text file. The data will be stored in the same generated format in the cloud, in the S3, Amazon S3, to save the historical data and then start after a period of time a batch processing to transfer the data to different format like Parquet, CSV file, and finally in the relational database to be ready to share with the consumer. Other cases like analytical data warehouse, operation data warehouse, and Lambda architecture. The idea actually for modeling these cases to make sure that the framework has the ability to model common big data architectures like Lambda, Kappa, especially Lambda architecture utilizing the 2 processing type, batch and real time. Finally, let me show you a short demo about the graphical tool. Finally, we could use a data architecture framework or framework to model a data architecture. Thanks for listening. Any question?